哎，欣姐，
Hello.
啊，你有没有 homework？
Question 7, 8.
Ooh,
Ignore what I wrote.
what subject? I mean, what topic is it on?
Pressure? Oh,
Okay.
pressure is balance and stuff.
Pressure is what?
Not pressure, right?
Yeah, it is. Let me just make a copy so that I can just use the laptop to show.
Okay.
And then I'm recording as well, lah. Huh? Put it up whether Fuji wants to watch or not. It's up to you.
Don't think you want.
So you say for your chemistry, you're all done already.
Yeah.
Oh,
Yeah, just count this one.
okay, but you finished the classwork.
Yeah.
Okay, great. Bring my laptop over.
How what?
No, because cannot connect through the Wi-Fi. Oh yeah.
What?
How about lose? Huh?
Is it?
Yeah, it is. It is. Yeah. since you never mind, I have a problem connecting. So I'll just tell you verbally one. Let me join this up again.
The what's it called? The chip reading that. Yeah, it's it was like that. But you need to this position really.
You need move, yeah. That means in this case, every other geography,
Then you really not.
yeah. 9 and that plus 2 is equal to yeah. Why the check that? That's fine, but what's of course, you have emphasized on this one that this drop load of the theory is not moving. So at equilibrium, that means the pressure on the net is equal to the pressure on the button. Or what? Every line go on. Over five. The 6 cm meter.
It's
So you the long column of the theory. Oh, okay. Okay. Oh, or then you set up the equation and you know.
quite great.
You're interested in U1, so U1 is under the pressure of this guy. The pressure is using the QE and the pressure of the which is atmospheric pressure.
You want graduate?
P1 is the pressure is something. So it's equal to the pressure of the QE plus atmospheric pressure, right? So the QE is very standard. So we will show you everything in SI units. Let me see, we can ask what unit. So, don't you know that easier? Only visual change. Because this 6 cm, right?
Yeah.
So 6 cm. Yeah, we still how many cm? You read 76 cm. So total is 82 cm. That is the pressure in T1. Yeah, okay. Right. Because they didn't ask you for units, therefore no need to convert to SI unit. Just the tricky part is pressure can be expressed as cm of mercury, cm of water, meter of water. Is always a length of a substance, typically a liquid substance.
Or this one.
Listen here, what's like that is something that okay. This one you set up the equation also now. No atmospheric pressure is here, right?
Yeah.
This is mercury pressure. This is T2. So set up equation also. So always look at the lowest part because the lowest part experiences the most pressure. And the lowest part is atmospheric pressure. And what is impacting on the atmospheric pressure? Mercury. And above mercury, you have this P2. That means your atmospheric pressure is supporting the mercury and supporting the P2.
Oh,
So therefore, P atmosphere is 76 cm, P mercury is 6 cm, assuming there's no change in height. P2 is, so you solve for P2, 70 cm mercury. Okay, so actually, if you think about it intuitively, this case mercury is, let's say you're inside here, mercury is falling on top of you, so obviously you better experience a higher pressure, which is 82.
okay.
But over here, your mercury is falling away from you. Imagine you're inside here, but it's falling down away from you. So obviously, if you are here, you are going to experience a lower pressure, which is only 70.
Oh,
Huh? You can come up from you before that range here. So. First thing, understand multiplication of pressure volume means P times V. Volume of what? Volume of this air. Volume of this air. Correct. So also volume of this air. Okay, so this under P0. The volume here is, let's take it, let's call it V. The volume here, we call it V1, and it's under pressure P1. The volume here is under volume V2, under pressure P2. So therefore, you still have to set up an equation like all physics question. P not equals to P1 C1. That's the meaning of P not equals to P2 P2. You know what is P not? Yeah, because here is atmospheric pressure, right? Anyway, told you that. Anyway, you are the one who explained it. So atmospheric pressure is what? 76 cm. If I can put 76 here. P not. Now think about it. What's the formula for volume? Well, it's basically the height times cross-sectional area. Okay, cylinder, right? It's like a cylinder. So cross-sectional area, let's call it A. It's the same for this side, for this side of the mention. So I call it A, cross-sectional area, so times A times length. In this case, the length is 42. Right. P1. Pressure is 82, right? Now, in this case, I'm not using SI units because as long as both sides use the same units, then you are still okay. So, that is the trick. What about cross-sectional area? Still the same because it's the same tube. QA. Right? But the height is different. The height is Okay, the height you don't know. That's what you want to find out. Yeah, L1.
Yeah.
So A cancel off here. Okay. Find out where's L1. Huh? Then you do the same for L2. Or same thing, right? P2, you know what P2 is 70. Cross section another area is A. You don't know what L2, so you solve for L2. Right. P not B not is basically this is the same as that's how you can solve for L1 and L2.
How am I supposed to know this?
It's very difficult. You have to figure out what they tell you. That is the difficult part. That is the difficult part. Figuring out this equation is not easy. And of course, this equation is not. For the method, even getting this equation correct probably is a challenge for you, right?
Yeah.
Same thing, getting this equation. Only thing I can say is normally I would look for the lowest point. That means in the system. Just for something else. So if you have a system like that, know there's something above. The one thing is what did they tell you this is water? Then above water you have oil. Then above oil you have something else. Can come up for cure. So my suggestion is look for the lowest point that you're interested in, let's say this point. So pick this point, let's say P naught. So P naught equals to everything above. Everything, but let's just call it substance X. And above here is atmosphere. So always look for the lowest point that you're interested in or in the system. So P naught will be pressure of water, plus pressure of oil, plus pressure of substance X, plus above pressure atmosphere. That's how you set out the equation. Look for that lowest point. Then what we want to change it. Then this lowest point will be the left hand side. And everything above will be on the right hand side of the equation. Water is above, oil above, X above, atmosphere above. You know, I'm doing all the same here, right? Where's my lowest point? Here, P1. So P1 on the left. What's above P1? Mercury. What's above Mercury? Atmosphere. Oh, what's my lowest point? Here, atmosphere now. Atmosphere is my lowest point, so equals to what's above? Mercury. What's above? P2. Difficult, I know. Pressure is headache for a lot of students.
I think you mentioned this, but I do have this.
Set out the equation. Left hand side is your lowest point where you're interested in the pressure. Okay, but this one is hell, no? This one is hell unless it's done it before.
Is it? Come on, before.
Once in a long one. This is not common, even for students.
My terrible luck, right?
We see this year, whether it comes up this year. If it doesn't, then there's a chance it may come up this year.
Okay, sure.
This, no, so you watch out for this year, over there.
Yeah. Then this one? No, what? Oh, bullshit.
You look. Take the lowest point of interest. And look up for. I remember. I don't remember what I said.
Okay.
Because you're not taking down notes, huh? Look for interfaces.
What?
Interface. This is one interface between your gas and water. I look for the other interface. Water and air. Right? Now, identify all interfaces. This is few straightforward. You know, there are difficult questions that have for you again, you again, you again. You know, they have a constant interest. Yeah, and then there are different substances like gas, mercury, water, oil, kerosene. You can't do that. This one is completely different. It should not come out. It should not once in a super long while. Wow, this is more for like Indian schools. So anyway, normally I would look at the lowest interface. This is higher, this is lower, so look at this one. And then I draw a straight horizontal line. Okay, and then curvature here equals the curvature here, agree?
Oh,
So you set up your equation. This is P1, and this part is P2, and they are equal. Interface 1, interface 2, this is lower, so I take this as the reference. And so P1, what is above P1? Yes. Okay, interested in that. What's above P2? Oh, good. What else? Atmosphere, good. Now, in this case, they want SI units, I mean more or less SI units, huh? So, no choice. So, okay, correct. What should we do? So, it's going to. Okay, which is of course this 8 row is of course your water. And density for water. Yeah, SI units, huh? This one. What's the atmospheric pressure in SI units? If they give you. Is it the. Yeah, we only issue this. Oh, this is not SI unit, yeah? No. Therefore, you can convert your SI unit load using load H. But in this case, H is 0.76 meter. Your rho is for unit. So we find out this is the atmospheric pressure. What's the SI unit? And then we take this thing and start into the equation. When you combine this together, we get your gas pressure. Beyond gas level. Yeah, but of course, we still have to convert it back to kilopascal because if you use SI units, everything will be in Pascal. But they want answer to be in kilopascal. So you have to divide by 1000. You want to work it out, then at least I can take a look. And then here again. I don't feel like doing it. But actually you can understand.
No, we're just not super
But this one definitely can come up for you this one.
not standard.
Yeah, this one is standard, very standard. We can argue that this one is not so standard, especially this one. This one is very rare, very rare.
When's the last time?
You can remember, if I remember, so about time it come out again.
If he does, I'm losing out.
Yeah, this one is good.
Then if it does come out,
How much? That's right, ID Because personally, I think unless you can remember, you're good in everything else, right? Then you can spend some brain power to remember this. Because if you're other struggling in other formulas and concepts already, don't waste my brain power to remember this.
how much mark? Like this question.
Probably it's a bonus question, so likely to be about too much.
Oh, no.
I think do something. Unless you're doing well in all the other formulas, then okay, remember it.
No way, it's gonna run. There's so many formulas.
Yeah, even you're struggling with this, But anyway, there's also no point recording it because Fuchin this will come out.
It's not my time.
It's not coming today.
Is he coming?
No, I don't give it. I won't have any chance to message him today. But anyway, this is not in the syllabus.
No,
It's not even in the combined science syllabus. It's only in here.
I.
Just go through set 3 first, and then decide in set 4 what you're going to do. Don't think wrong. Yes, prepare the document first.
It's constantly that.
Like one set 4 student drop. Not say drop, convert from 2 pure to 1 combined.
Then we announce something.
This year, one less subject to be examined.
But does it affect any?
As long as you have the correct number of subjects to include in your aggregate score for either JC or one, then it doesn't matter. How many subjects you have in total? As long as you have 6 subjects for JC, the 5 correct subjects for 4B, then it's good enough, really.
Oh, yeah.
Student is also quite smart, I would say, in the sense that you prefer to have 1A for the combined side rather than 2Bs for the 2 overall side. That is relational, that's all relational.
So follow me.
But you still actually you can do it at the end of that 3.
No way I can hear that. Yeah. Atmosphere. Light.
Atmosphere is given by this, right? 76, huh? 76, so when you separately convert, from 76 cm of cubic to Pascal using this formula.
Oh. Use the formula you can.
Yeah, but make sure it's SI units.
What?
Maybe this must be better.
Like that.
Yeah. That's the answer in Pascal.
Oh, Pascal.
Yeah. Very common forget, but try not to. Just like not too bad, right? Huh, this still don't need to do. I do that. Okay. Please. Oh, anything else? That's all. Thank you.
Have maybe
What?
next week.
Oh.
Don't know.
Okay. I suppose you didn't watch the video I posted last week, right? Okay, then I just quickly go through the next topic for your school. Heat transfer. But that one should be okay. You've done it in lower side.
Some calculation.
Let me see. For you,
Oh,
for you, yes. Didn't see what?
Didn't see the message.
From me.
Yeah.
Oh. Okay. Come, let's just show you what the easier parts first. How familiar, right? Conduction, convection, radiation.
Oh.
Huh? Or what? Or here? Yeah. No calculations yet.
Yeah.
For you.
Like what?
No, coming soon. For them, no calculations. For you, there are.
What? Oh, sorry.
Yeah, amount of heat.
Oh.
In joules. Okay, I'm too tired. Let me use this. Okay, you want to take down some notes? First thing first, this is the primary school concept. Always look for difference in temperature. Where is the high, where's the low temperature? That is important. You have to know heat transfer is from where to where.
All right.
If you can remember, no need, but if you can't, remind yourself, write down to remind yourself.
What do you know?
To analyze the question. Otherwise, you're already going to scroll your answer if you don't know how the heat is moving from where to where.
Oh.
But anyway, this primary school start, right? High to low temperature.
Like
You have forgotten.
almost.
Almost. Try not to. Okay, next one. There are three heat transfer mechanisms that often come up, even though there can be more. So I'll just tell you the three standard ones: conduction, convection, and radiation. And even though I didn't write it here, if a question comes up, you have to identify whether conduction, convection, or radiation is occurring, because your teachers will be marking based on this confirm. So anyway, how do you know which one? Is it conduction, convection, or radiation?
This
See, see what?
the question. Let's see. How does the transfer is? Sorry.
Yeah, but I'll give you a very simple advice. Look for your question. What is the system there? Is it made of solid, liquid, or gas, or vacuum? Correct. Only 4 possibilities. Actually, all this is very. Let me give you the short version. Imagine I have this system. Okay, it's a solid. Okay, no, this is not very good example. Let me redraw that. So I have a solid. Hot, cold. Tell me, heat transfer left to right or right to left? Yes, better know that. Oh, I didn't mention this is a solid.
Oh.
Then what mechanism? Yes, because it's a solid. So yeah, too easy, right? Conduction. Okay, I'm using another way to teach now. Right, I'm using a simpler method for you. But for you, there are two kinds of solids. Yeah, two kinds. One is non-matter. The other is matter. Of course, you make sure you know what are matters and non-matters. All right. Aluminum is metal or non-matter? Lead. Yeah, it is. Because in physics, there are no periodic tables, so you have to remember in your head.
Oh.
You can't look at your staircase, in physics. Well, then you get into big trouble.
Oh.
Now, the issue is why differentiate? Because for non-matters, how does conduction work? Basically, propagation of vibrations.
What?
Let me write this down first. Vibration of particles in the metal, of course. I mean, in the solid, of course. Okay, I'll tell you very soon.
Don't use fancy word.
These are the words you need to use in your answer. Okay, anyway, actually it's very simple, no? Imagine where is my hot part here, right? So this hot, the more atoms, not atoms, let's call it particles. You start to vibrate, correct?
Yeah.
And they vibrate more vigorously because it's hot. Then what happens to the vibration? Vibration will spread. They will spread towards the right-hand side. Correct. So the spreading is called propagation. It propagates from left to right. Get used to the word propagation.
Propaganda.
Kind of. Okay, so vibration, it basically a transfer of kinetic energy from the particles on the left towards the particles on the right. Can understand this one?
Okay.
Right. And what else? That's for matter. I mean non-matter. But how about matter? For matter, you have the same thing. Alright, vibrations will spread from left to right, but there's something extra. For matter, they also involve the movement of free electrons.
Movement.
Of free electrons.
So the way this propagation of final.
Yes, but in this case, the electrons actually move from hot to cold region. They actually move. They don't just vibrate, they move. So basically for matters, you have to mention this part and this part when they are asked about conduction. Now, physics will not ask this, but I will. What are the free electrons?
Huh?
Where are the free electrons? How come there are free electrons in the metals?
Extra.
Remember, in chemistry, what is metallic bonding?
Your localized electron.
That is the answer. The free electrons is referring to the sea of delocalized electrons, even though physics will not require you to answer like this.
That one right in.
Well, probably the guy should understand what you're saying. He will still mark you correct. Okay, so that is the solid part, easy, yeah. But what if I have this thing? I have liquid. Yeah.
Convection.
Yep, good. The liquid, huh? But let me finish writing first. So this is cool. This is warm. Well, of course, heat transfer is from bottom to top. Mechanism, yeah, right, convection. Okay, but what if I have this situation? Again, I have a liquid. In this case, my top is warm, my bottom is cool. What is my heat transfer direction?
Downward.
Downwards. What's the mechanism?
Convection.
Nope. Convection doesn't work. Come. So which comes the important rule? Convection only, better write this down, transfers heat upwards. That's something you can't forget. It's okay. Make sure you remember correctly in the exams. So back to the story here. What is my mechanism? It is conduction.
What?
Because it can transfer in any direction as long as it's from hot to cold.
It's mentioned last time.
Oh yeah, it was.
Huh? But the last time they call it a cycle.
Yeah, coming soon now. Later you still have to draw the cycle.
I'm confused.
but you may want to highlight conduction is inefficient, slow and inefficient compared to convection. So it takes a long time for the bottom to warm up. Yeah. Later I'll show you the cycle since you love it so much.
Oh.
Lastly, what if I have this case here? I have a hot object. Let's use it. Okay, I have a hot ball over here, and then surrounding your hot ball is air.
Wow. Hot ball to air.
Yes, first identify the direction. But of course, I would assume the surrounding air is quite cool, so heat transfer occurs in all directions. What is the mechanism?
Conduction.
Conduction, yes, a bit, but very, very, very slow because can you write down air? Remember you learned in primary school?
Oh yeah.
Air is a poor conductor of heat. So conduction is going to be very, very slow.
What's it called? Radiation.
Yes, correct. So therefore, in this case, heat transfer mechanism is by radiation. Conduction is going to be very super inefficient, worse than in liquid.
Yeah.
Okay, but I'm not done. Under radiation, there are 3 words you need to remember. Tell me, in this case, is emission or absorption taking place?
Yeah.
Good, make sure you realize it. So in other words, this object is emitting radiation. But Jingjie, just a note, the air is important because radiation goes through air very well. That is the key. It must be air here. All right, otherwise something else will happen.
Something else.
Like for example, what if it's like that? I can give you all sorts of silly examples. I mean, not silly, but let's have the same diagram, but change it a bit. I get rid of my air. Right. Instead, I have water. You have this hot object inside water. Huh? Yeah, of course, the direction is still the same. It's still going in all, I mean, the heat transfer is in all directions, but tell me, what's the mechanism?
Oh.
This case, you have a hot ball, you drop it into water.
Oh.
What is the mechanism?
Convection.
Good, but don't forget, this one is complicated. Hopefully it won't come up for you, but you know for sure, you never can tell. Right.
Convection.
Yes, good. And it depends on the direction. Hopefully it doesn't come out. So far, I haven't seen this coming out yet.
Yes.
Yes, yeah. So you have convection. Radiation doesn't go through water well, remember that.
Can happen.
Can, but it's very inefficient.
Do we count it?
No, usually not.
Oh.
And then for the other kind of directions, especially sideways, maybe not so diagonal. Let me remove the diagonal one. If I'm talking about sideways, or even towards the bottom, then it's by conduction.
Actually,
Oh, okay, I'll tell you very soon, since you like the cycle so much.
no.
Can you see the yellow? I shouldn't use yellow, but should be. Can see? If not, I redraw.
Yeah.
Cannot. Okay, so this one is tricky. Convection upwards, sideways, downwards, conduction. Radiation is almost zero. But anyway, water is still a poor conductor of heat, like what you learned in primary school, even though it's better than air. Okay, but I'm not done with this guy yet. Let's look at this guy again. Now, same thing, I have the ball.
Oh.
Okay, but in this case, I have a cold ball.
Oh.
Yes.
What's that?
It's taken out from the freezer.
Oh.
And then surrounding the ball is air. Tell me, where's the direction of heat transfer?
Air to cold water.
Good. Mechanism?
What? Oh, mechanism. Conduction.
Air.
Really?
Yes. Okay, it's by radiation, mainly radiation. Conduction, I mean, there is, but it's going to be quite pathetic compared to radiation. Lastly, because this ball is taking in radiation, so we'll call it the object is absorbing radiation. Yeah. So the word emitting and absorbing typically applies to radiation, not conduction and not convection. It's going to come up confirm emission or absorption. Oh, yeah, it's a traditional question. And the last one, okay, maybe not last, but next one. How many? Yeah, quite a lot.
Oh.
This one very standard.
What?
The key is if you ever see the word vacuum, there is only one possibility, which is what's the mechanism?
Really?
Yep.
Sure.
Radiation is the only answer. No conduction, zero conduction, zero convection.
Okay. Where to write this now?
Well, why not? It has come up before.
Yes, sorry.
Yeah, they talk about the sun, earth, and what's in between.
But
Sun and earth. In between will be outer space, which is a vacuum.
oh. They ignore the planets.
Normally the planets don't go between the earth and the sun, right?
Oh, you know.
Otherwise you have an eclipse already. So anyway, make sure you know, obviously this is emitting, earth is absorbing, and of course, the radiation goes from sun to the earth through vacuum. Okay, now what else do I need to tell you? Come, let's go to your favorite one. Awesome.
Oh.
Okay, let's start from the beginning. Yeah, you need to write a long story.
Oh.
Now, first thing, convection only in fluids. No vacuum, no solid.
In fluids, nothing fluid.
Yeah, it does. So actually, I forgot something. Because if you want to be very particular, let's go back to this example, this one here. There is actually a second element that I forgot to mention to you. Because there is an upward transfer of heat as well. Because surrounding is air, so you will also have convection upwards, not just radiation. Okay. Okay, let's go back to this one. Come, start writing your story. When they ask you about convection, you have to write warm fluid expands. Warm fluid. Yeah, let's say you have a pot of water, you heat it at the bottom, so the bottom here is warm at first. So this one expands, continue writing, density decreases. Hopefully remember this formula, even though you don't have to write it in your answer, but this explains why the density decreases. Mass is the same, volume increases, so density decreases.
Oh.
Then anything of a lower density will rise. So as it rises, it transfers the heat to to the upper level. It loses the heat to fluid in upper level. Then you continue the story. The cool fluid is denser because it's cooler, so it sinks. So this is the part that rises, the rising part and the sinking part. So as it sinks downwards, it will replace your original fluid and then it gains heat. Okay, the one that sinks downwards will gain heat when it's near to the heat source. Okay, so it's over here. Then by now you should know what happens. The cycle repeats. So it sinks, rises, sinks, rises. So the cycle repeats. And make sure you input this term in your answer. Convection currents are formed. So in this case, I have drawn 2 currents only. Of course, in real life, you have a lot more than 2. Okay, so there's a current clockwise and anti-clockwise current. Yep, that's your favorite one, convection currents. Make sure you write the full story. If you write the full story, this is typically 4 marks question. 3 marks are usually 3 marks. And 静姐 tired lah. Yeah. Oh, I didn't mention this, but can you also take note? Conduction can occur in any matter, solid, liquid, or gas.
Yeah.
But in solid, most efficient, followed by liquid, lastly, gas. conduction, solid, liquid, and gas. But for you, since I'm pure, they may ask you,
Wow.
why is it most efficient in solid?
Oh, because particles closer.
Mm.
Heat transfer faster.
Okay, actually you get the idea because they are closer together, they are close together, so the vibrations can easily propagate from one atom to another and hit a nearby neighbor. Yeah.
One word that word heat transfer.
You try like you're going to see that word again later on in another chapter.
Ah. Okay.
But convection only in fluids, just remember that. Radiation only in, I won't say only, but in a vacuum, definitely. In a gas, yes. In a liquid, very weak. In a solid, almost none.
Everything.
I think for O levels, you just put in a gas and a vacuum.
Oh.
In liquid, it's very rarely, almost nothing. For solid, there are only certain solids that can allow radiation to pass through, but you don't have to know them. But radiation got a few things you have to remember. 4 factors. And you may want to jot them down, definitely coming up. Maybe not all 4, but at least 1 or 2 of them. Okay, 4 factors that affect radiation.
What is texture?
Texture, why what?
Doesn't matter.
Actually, you think about it. A rough surface, what's the difference between a rough and smooth surface?
Once smooth rough. Smooth.
Rough means like that, right? Rough.
Yeah.
Under microscope. It also means there's a lot more surface area.
Oh, okay. I thought smooth was normal.
No, smooth is totally flat. Nothing. Just flat. Everything written down.
Oh, you mean right? Everything.
Yeah, everything. Any of this can come up.
Like this. That's wow. I see.
Okay. Let's go through some examples. Now, take note. Black means if it's a good emitter, it's a good absorber. All right, so everything depends on the temperature, whether it's emitting or absorbing. I think just now you can understand that one that I showed you, right? This one. All right. So therefore, if this guy, if this guy is black, then it is a good emitter. And likewise, if this guy is black, then it is a good absorber. Okay.
Then, okay.
Okay. I mean, I'll reverse. It will be reverse. If it's white, then it's a poor emitter. If this is white, then it's a poor absorber. Simple as that. Likewise for texture, if this one is rough, it's a good emitter. If this one is rough, then it's a good absorber. Okay. Okay, what else? Surface temperature, I think you can follow. If let's say I have two objects, same size, same material, same texture, same color, which one is emitting better? Yeah, of course, higher temperature. Now, likewise, I can also reverse. Where's my other example? Let's say I have these two guys again. Which guy is a better absorber? Yeah, minus, because the temperature is lower compared to the surroundings. Can okay, shouldn't be too difficult. Now, surface area, I think you should be able to understand, but I will want you to remember one last thing. Now, think about this. This guy is cool. All right, it is white.
Yeah.
So, can I say it's absorbing radiation from the surroundings? Can I?
Yeah.
So, is it absorbing well or not? Is it a good absorber? No, right? So, what happens to the other rest of the radiation?
Fly.
Well, Jingjie, that's where I want you to take note of this word. For radiation, you occasionally have to use this in your answer, reflection. So in other words, it doesn't absorb well, correct? Because it's white.
What?
It's white, so it doesn't absorb well. So basically, it reflects well. It absorbs poorly. Right? It doesn't absorb because it reflects.
Did I teach this last week?
No, not this one. Not in this manner.
No.
Not exactly like what I'm telling you right now. Because lower side, they don't emphasize too much on it. So anyway, the moral story is this one. Jingjie, take note of these 4 sentences.
Wow.
Good absorber is a poor reflector. Poor absorber is a good reflector.
Why?
If it absorbs well, it means it reflects very little. It absorbs the radiation. It doesn't reflect the radiation.
Like.
Actually, radiation is like. Later I tell you, since you asked about it.
But you must say something right.
Well, you have to know anyway.
Right.
What it's like?
I don't know. Energy.
Okay, never mind. You write down all this first. This third and fourth sentence you can follow, right? Good absorber is a good emitter. Okay? And therefore, good emitter is a poor reflector. Okay, back to your light question. What is light?
What? Yeah.
Yeah, what is light?
What?
I'm going to answer you, so you have to write down because you need to know this in a chapter very soon.
Like.
Oh yeah, I mean, yes, it's a radiation, but well, you have to know more than that. You have gamma ray. You have X-ray, which I'm sure you've heard of it. You have UV light, ultraviolet.
The new water.
Yep. Ultraviolets. You have visible light, which you see every day. You have infrared. And I believe you have seen this word too.
Okay.
You have microwave.
It's microwave.
Yeah, microwave is considered
Like the sugar.
yeah. You have radio waves. They are all considered light.
Oh, light.
But what you need, you need to remember this, maybe not now, but sooner or later, and and in this order. Visible light, of course, you can see, human eye can see. But what I want you to emphasize is infrared. This is your radiation for heat transfer. When they talk about heat transfer using radiation is by infrared light or infrared waves.
Wait, what?
Waves.
Oh.
Radiation as heat transfer. Okay, for the rest, I won't mention anything yet, unless you want me to. Otherwise, you leave it for another day.
What do you see them for?
How do you see them? You can't see them. You can only see visible light.
Oh, no.
You need other methods to detect them.
Then how? They're color today.
No, they are not visible, so they have no colors. You have to use, like, let's say, photographic film to detect X-ray.
How many?
7.
7.
Yeah. Anyway, yeah, sooner or later, you have to remember them in this order, as well as their users. Okay, anything else I missed? Let me see. All right, radiation, I think you should already understand. It can occur in any direction. You know, there's one question. Let me think. What is the question? Okay, I don't think I want to tell you, but
Yeah.
was one question about the oven. Yeah. So imagine a simple one. Let's keep it simple. So imagine you have this oven. Then you are preparing food inside.
It's the
Chicken. And then you have this heating element at the bottom. Metallic heating element is very hot because you run electricity through it.
Okay.
Of course, you can ask you all sorts of questions, calculate electrical current, calculate voltage, calculate energy, calculate heat produced and stuff like that.
Voltage, yeah.
Voltage. Voltage is your battery. Your battery has 1.5 volts, 3 volts. It's the force that pushes a current through the circuit.
Oh, I remember now.
Okay, then they ask you, how does your food get cooked?
Yeah.
But you answer in physics terms, right?
The heat.
Then what about the heat?
Heat transfer.
By what mechanism?
Radiation. Wait, no, what am I doing?
Possible. What is inside the oven? Surrounding the food?
Metal.
Okay, that is the casing for the oven, but what is between the heating element and your food and your chicken?
What? The player.
You know, I mean, there's a plate. Yeah, okay, okay. Let's ignore the plate.
Air.
Otherwise it's complicated. Okay, imagine you can suspend the chicken inside the oven.
Nice.
Yeah, you can. Okay, so your answer should mention what is this mechanism?
Oh. Convection.
Okay, convection, good. Then you have to mention that whole long story, density lowers, rises, sink, convection currents are formed. What else?
What else?
How does your whole chicken get cooked?
Oh.
What is inside the chicken?
So
Solid, mostly solid. So what's the mechanism?
conduction.
Yep. So to get full marks, you have to mention this.
God.
Yeah, it's a rock to write easily 4 marks. 4 marks.
Okay.
Okay, can follow what I'm trying to say?
TYS question.
Yeah, one sometime back. I remember which one.
Wow. So much. Wait, was the diagram actually like that?
Somewhat, even though I think I drawn better.
There's no plate.
There's no plate.
So they just pretend it's floor.
Just suspended, use a skewers or something to hold it in the end.
Oh, I thought it was a brick.
You want plate, you want plate even more to write.
Wow, plate. The heat transfer to the plate. The plate get hot, then the plate transfer to the chicken.
Of course, the plate, how does it transfer heat through the plate?
What? Oh, conduction.
Yeah, conduction also. All right. Okay. Any final questions?
No.
You have time to do homework?
Oh,
This one, no.
how the homework?
No. I will print a worksheet for you to go back and do.
Oh. Yeah.
Yeah.
Okay.
Okay, come. Alright, let's clear out first. Let me print it at the printer because there's another class coming in.
Okay.
Just wait for me at the counter.
This switch in it.
Oh, yes. Thanks.
I never seen it at all. Why?
Medical issue. Until we have to know how we do the patient.
I need to change myself before sleep. Now the cancer. One goes for another 10 ever again.
I think there should be more coming, right?
But what?
It's like end of the year, there's probably be another time to do.
Well, still one.
Oh.
You not sure I was. But I think the chill one, right, we might they might cheat me so. Yeah, actually the chill one, because now I'm actually I need to sleep less, so the one for comfort. I just want to step down.
Step down.
Right now. Yeah.
Just now block 今天那个
Yeah. What's the
OK 啦，只是有点 interesting。你到能够去做是吧？
Oh, got chair.
Yeah, new chair. Actually not new. From Sam.
Sam.
They closed down already.
They give up.
Yeah.
They give donate.
Yeah.
Hey, where the tank go?
Yeah.
The tank.
Oh yeah. Oh yeah. Drop to the back lah.
Ah.
Let's go. I haven't had time to pick it up.
I thought you put in the box.
Plus, somebody go and drop the thing.
Wow.
Oh yeah. Haven't had time to pick it up. Let me print it up for you.
That means we do better.
Heat transfer.
Okay, back to you. And the fact that I'm not able to catch us. And like it's very big plan. What if I don't do well? I see.
Yeah. You know why? Your bio, you know, I still already the very first lesson, right?
I don't
Your
do
bio, I don't know your bio data.
Is it
put
British?
on your.
Nope.
But it,
Yes.
I already told you,
Yes.
it's reading, so how, is it the same thing?
No, I'm starting to catch up, but yeah, so that's too much.
But you really got to let's pick up the tools and all that. Start reading and then I told you, your 3 point, so down again.
Why you got Milo?
So
For the kids,
all
for primary school kids,
What is this?
for championship,
What championship?
competition now. For their how well they do, can answer questions, score point.
Hey, how come last time don't have?
Yeah, last time only you and a few others Okay, this is for you. Yes, keep it easy.
Okay, then like she has got good questions. Point out the good points and strong points and all that. Like the last one you go, when's the one like to ask you for the
English will start in October.
so that one,
Yeah, mid-October.
generalization.
For science is 10th of October to like almost middle of November.
No, so like
1 month,
your
1 month plus.
okay, I think, no, or SW, but like correct,
1 month
like advanced
within
both the
4
pointers.
weeks, like 4-5 weeks.
Okay, but then I straight out that you go ahead.
Yeah, it's special one. Like even for the pure, don't forget still got practicals.
The present, the one right, That one, right?
Okay.
How about okay, so let's go through there. And first, if you got any questions,
Paper two.
I will like really question last week I really got.
And then last one is
Then
the
I will go through you. Oh,
MCQ.
I don't think they're really okay.
They are all on different days.
Essay and.
Oh, I thought they will put the Q and
the structure in the very
no.
Okay, separate.
Okay, so.
More PMCQ. So first subject, that means we are physics, chemistry, and chemistry.
I think so.
I wish they give math.
Math for MCQ.
I don't know. Math got MCQ.
I don't think so. Don't think so.
Oh, the counselor one, yeah, okay, so you can take on.
Ah, okay, okay.
Okay, I like
ECG. Education, okay, all right, research.
okay, bye bye.
Then I will like briefly run through together. So what the trailer for this one movie. So actually my exercise is significant. Yeah. You saw it so full fortune really. No. Good. He said it was good. Was it good? You find it good? I didn't watch it, huh? Oh. But I think it's because she fell in love with a human or something like that. Yes. Huh? And then it was the white man, right? Yeah. So it was because of that, there's some racial thing. No, more than because she's a mermaid and she's not supposed to marry some human, something like that, right? Oh, yeah. So I saw the trailer, I thought that was sad. Then in the end, what happened? What happened to her and her life? Because she fight for her, right? Yes. Then what happened? The end they come together. That's all. I mean, in the end, it's still got. That's good, right? It's a good ending. All right. Sex, but sex. But then what's your opinion about it? You said it was good. You know, that's all you told me, last week. But then what was it? I love her vocals. I love all the singing. Yeah. She's actually a singer herself. She sang all the songs, right? Yeah. Who's she? Polly Baby. Polly Baby. Polly Baby, but she's a new actress, right? Never heard of her, right? It's not that Haley Bailey, the one for the Guardians of the Galaxy or something, right? Who's that? Another same name, Bailey also her last name, but she was Haley Bailey, the Guardian of the Galaxy, right? The actress also African, African American. Negro, right? No, I'm not that one. And okay. She's a entirely new actress I've never seen before, right? Ruby, yeah. Oh, okay. So, she's a singer, is she? Yes. By profession? Yes. Is she a well-known celebrity? Like she only got well-known because of. Oh, because of this, because she sang the theme song. Oh, but then. Okay, what else? Okay, you like her vocals and she's speaking. Okay, I guess. I mean, everybody has got their own benchmark, lah. Yeah, okay. Yeah, that's about it. The storyline, you like the story? I guess. Oh, I mean, it's the same as the cartoon. Or the cartoon version. Yeah. I did watch. I know there was this because of it, partly of the story. Okay. Then, but the one the king was the father, right? Her father, the father, that killed him. That killed him. Oh, but you watched the movie. Oh, you didn't watch. I thought you watched the movie. Oh, okay. So it means it's like okay. But you all go together lah. But you never watched that. But he did now. Oh, okay. This was like very good. And I happened to see the trailer, so I just wanted this.